Okay. Okay, let's start again. So today we're gonna talk about Kubernetes on cloud native aspect. We're not gonna do anything technical, but we're gonna go through the course curriculum. I'll run it again. Apart from learning everything about Kubernetes, we're gonna dive in depth into Kubernetes on deployment sites, config maps, secrets, and including some how to upgrade the Kubernetes and how the Kubernetes architecture works. Different components, including kubedm, which is if you're using as an administrator in your local machine. Different tools, kubedm, kubectl, and if there are other components that's Kubernetes. We used to manage Kubernetes, which, as you can see, the other platforms, OpenShift or Rancher. We'll go through them. Rancher is the one that I'm most likely to use to demonstrate on different platforms. But we're going to go in depth on Kubernetes. But again, we're going to learn all the other things that's on the peripheral of the Kubernetes. Then when you go to an organization, you 60% of the time you'll be working on the other tools other than Kubernetes. So that's why I want to touch everything. So you'll have a full understanding on how the cloud native architecture, or even if they're not cloud native, they're on-premise and then using Kubernetes on-premise, then what kind of architecture that they'll be having. The final goal is when you go to an interview, if you join an organization, you need to understand the whole picture of end-to-end architecture on from pushing the code to monitoring the deployments, the CI part, how to build the containers, how to build the images, how to push them to the registry, and how to pull them down. And again, Helm comes in as an package management for Kubernetes. Initially, we'll be doing hands-on on deploying components or pods or services, even secrets. But when you want to automate everything, it needs to be packaged into an usually Helm packaged into an artifact that we'll be downloading the artifact, and then we'll be substituting the values and then do the deployment. So because that is part of the automation that we're going to talk about. Again, we're going to start with Docker. We have Containerd, CRI-O, and Podman, the other runtime engines. But we'll be mostly working on Docker as the first runtime engine, and Kubernetes, initial versions of Kubernetes, they've used Docker before they moved to Containerd. So in Docker, there's a Docker Swarm, which is a Docker orchestration tool, which we are not going to touch, which is out of scope for this course. But we're going to touch on basic Docker, on how to run a container, how to build an image, how to do Docker in Docker images, which is called DIND, and how to do two-stage Docker builds. So which is critical, because if any application that comes onboarding into containerization, most of the application developers, they don't know the concept of two-stage Docker images, which I'll go brief. I mean, we're gonna talk in depth on this, and we're gonna do hands-on on Docker in Docker and Docker two-stage deployments. That I initially is like two-stage Docker deployments. At the first stage, you compile the code, and the second stage, you build the code. So that is something that we really need to understand, because sometimes because we used to, the old days, we used to compile it. If let's say Jenkins is the one that everyone using, so we'll be compiling the code as part of the Jenkins build. But once it moved to containers, we want to the applications are lightweight, and we want to compile the code in a container as well, and at the same time we want to package it as an image. Yeah, so this the runtime engines and Docker will be the first technical concept. Then we're going to dive into Kubernetes. So this is the basic high-level architecture. We're going to go in depth on each of these, including etcd. Most of the time, you will not be, even if it's very rare that you'll be come across that you'll have to run against anything on HCD database, but we'll be working on an HCD Kube API server scheduler controller. So this is what you call control plane. We're gonna go deep, talk more on that. Then we're gonna have kubelet, kube proxy on the Kubernetes architecture. So these are the core components of Kubernetes, but then there are config maps, secrets, volumes, ingresses, services, uh, a lot other things that combine when it comes to Kubernetes. We'll be discussing as them. Then we'll be talking about cloud Kubernetes in cloud, which is managed Kubernetes services. We have Amazon EKS, we have Azure AKS, and then we have Google Kubernetes Engine. So Google Kubernetes Engine is if someone wants to use Kubernetes, some organization wants to use Kubernetes without going into any other option, and if they need to be in cloud, they'll most likely go to GKE, which is highly adaptable. They have developed it for a cloud adaptability, which compared to which is because Kubernetes is coming from Google, so they have more tools, more capability in GKE than the other clusters. For an example, right? There was a news couple of months ago that GKE did about 60,000 nodes. So a node is a worker, which is called worker node, which is usually, if you're in cloud, it will be an EC2 instance, which if you're in on-premise, it will be a virtual machine. Or if you're doing, even it could be a bare metal, but a node is something that you run your workload on. So the control plane is a separate that manages all the controls. Usually, if you're starting as like if you are good, you're dipping into the shallow end of Kubernetes, you'll be starting with the control plane and probably 3 or 5 nodes just to start with it. But there are organizations that we use in thousand nodes, 5,000 nodes. But as a record, GKE did a 60,000 node cluster as part of training their AI modules. Again, Azure has AKS, Azure Kubernetes Services. Amazon has EKS, which is a very famous. So we'll be touching on EKS, on how to deploy EKS and how to manage an EKS cluster from CLI or from the AWS console as well. Then we're gonna jump into platforms. So most organizations would have, if there's an organization that has more than one cluster running, that means if it's just a simple environment, you'll have a development cluster, probably a staging cluster and the production cluster. But there are organizations who are running more than one cluster. So there was a Gartner a survey that 75% of the organizations on the Fortune, I believe, if I remember, it's just Fortune 500 companies, they'll be working on more than 5 clusters. So if you're working on more than 5 clusters of Kubernetes, you need a platform to manage all the clusters from one step. So these are like one-stop shop. So OpenShift, obviously from Red Hat, they have platforms to manage multiple clusters. Even if it's just one cluster, they have OpenShift, and then we have Rancher, which can be integrated into manage EKS clusters, any cloud service clusters, or on-premise clusters. And then we're going to dive into configs and secrets. Mostly the secrets that I want to talk about this part is we're going to talk about configs and secrets. We're going to do it them manually first, and then going to come to manage services for secrets, which is HashiCorp Vault, which is the famous one. And then we have AWS Secret Manager. And we will talk, the HashiCorp Vault is a licensed product, but I think we do have a free version that we can leverage on at least how to interact with a Vault. And then we're going to jump into CI/CD. We'll talk more on CI/CD. We'll be talking on GitLab. So these are different tools. So GitLab and Bamboo, they're the same thing. They store your code. I mean, GitLab pipelines and Bamboo, they're the same thing. They store your code and run the pipeline. So you can run your pipeline in a Bamboo or a GitLab pipeline or Argo CD or a Spinnaker, anything. We'll go through all of them. And when it comes to Artifactory, we'll be talking about JFrog Artifactory on how to store images. But we'll starting with storing images in Docker Hub. So I'll let you know some homework once you go home. You need to open some accounts in some of these services to start working on from our next class. Then we have infrastructure as a code. So mostly at Ansible for automation. If you are new to Ansible, we'll be going through a brief Ansible introduction. And then we have a concept of GitOps, which means that the concept of GitOps means that the truth lies in your code, which lies in the Git or GitLab, whereas um, then we have a Jira. I mean the Atlassian, the tool of box. They have a Bitbucket. So your truth, the truth which they say that is not on the cluster or the node that you're running, but the actual state of your entire architecture lies in the code. So what GitHub does is it relies on the code. If there's any changes in the code, it comes and make your changes in the cluster. If something we manually change in the cluster, whether it could be Kubernetes, EKS, even something else, like doesn't have to be cloud native or containerization. GitOps means that truth relies on the code, which is on Bitbucket or Git or GitLab. We always the once we automate it, it always relies on it. Even if someone goes and manually change something, there will be tools picking up that change. For example, if it's Kubernetes, if it's Argo CD, if you're using Argo CD, Argo CD will pick up that change, and it identifies it's different from the source of truth, which is on the Git, and it will revert the changes even if you do something manually. So that's GitOps. We'll talk more on GitOps as well. And then we have Ingress. Ingress is on how to route your request within a single cluster, or if you're having hybrid clusters, that means you have a cluster on-prem and then you have a cluster in the cloud, but you have you need to route your request based on the geo IP where it's coming from, or based on the load, or based on the time of the day. You'll be routing your request to the cloud or your on-prem clusters. So that's what's called hybrid. So the Ingress, what it does is it's routing requests based on predefined rules. And of course, we have internal routes, which we'll talk when we talk about Kubernetes. So highly we'll be talking. So these are all the technical parts. And again, like I said, we have day 2 training on how to start a job on your first. If it's your first day on your new job, we'll give you training. I know if you have training on most of these tools, then yes, you really don't need to learn that if you're new, if you haven't used any of these tools. But this includes setting up local environments. So one of the tools is like, once we work on this, we will be working on your local machine. But eventually, once you go to the organization, you need to set up your local machine. So everything you do is from your local machine. You'll be authenticated to different clusters, even if it's cloud on-prem, and you'll be working for troubleshooting or a quick test, deploying a quick test. We'll be working on from your local machine. So we need to set up your local machine to work with them efficiently. And one of the things is like, so we have CLI tools, but once you start working on it, let's say, for example, like if you don't understand it, don't worry, we're going to talk about more. But let's say if you want to find out that the number of pods that's running on a different namespace, the command would be kubectl get pods -n and the name your namespace, right? So we are not going to type kubectl every time. We are not going to run, we are not going to append -n namespace every time you run a code. So there's different ways that we can efficiently use it. One of them is alias, or we can use some functions I'll let you know some functions for your bash script in your local machine. These are the things that we need to go and set it up that shows that you're more experienced on working on Kubernetes. And then again, generative AI, like I said, we'll be doing a one day workshop after the course completes. So this lets you, this includes prompt engineering. We're going to leverage generative AI on Excel on your day-to-day job. If there's any troubleshooting, how to ask the exact question to help, then it will, and then generative AI will let you know how to troubleshoot from grounds up. But one thing you need to be careful is don't do everything it asks you to do, because they assume then you have to give some kind of safety rules when it's when you ask the question. So if you're not setting up safety rules with generative AI, especially when you're I mean, you have to give this as a prompt as prompts, because if you don't do this, they will like the AI will let you do different things, assuming that this is your own cluster, not a production cluster, or not a cluster from a different organization. It automatically assumes this is something that you run on your local set. That means that you can do anything you want. They will ask you to do different things, but you have to set your rules on generative AI when you troubleshoot and you work in an organization. But of course, if you're doing something in your local machine, you don't have to worry. You can try it out, and that's what we're going to do. We'll have you try out different things in your local cluster. So either it breaks or it works, or it breaks, but we'll learn something. But we need to understand how to set up safety rules when we are talking to generative AI. And at the end of the course, of course, we have career support. Uh, so we will also have the mock interviews, but at the same time, we will uh, optimize your resumes, optimize your LinkedIn. Of course, LinkedIn is the best way to find jobs, other than if you go to the websites. Like I said, we are working on an AI agent tool that will automatically go and hunt jobs based on your criteria, whether you want to work corp to corp, whether you want to work only remote, whether you are open to move. You can set up all these criterias, and it will go and apply for jobs on your behalf, and it will also send you resumes. And we are working, and I cannot say for sure, but it should also be able to reply to your emails that in messages, that messages you're getting from LinkedIn. Don't need to work on it. You can set what kind of you can set up pre-message to reply, which means you don't have to work on LinkedIn at all when you're looking for jobs. And yes, so we'll do this. Right now, it's only LinkedIn, but we probably see if we can leverage that for other job searching sites. But all of this is on top of the traditional recruiter network. We have, I mean, not some the recruiters that we are working with are not from our company, like we are not paying for them. We gathered a database of emails or recruiters from the internet, from the LinkedIn, and from the other sources. What we do is like we pass in your resume to them. Yeah, and eventually, like magically, it will end up in some database, uh, which they will manage, because I have no insight into the recruiters world, how they manage, how they communicate with each other. But once we're gonna pass on your resume, it will end up in some database, and they will be reaching out whenever they receive a I mean, because they'll tag your resume in what expertise that you have, a Kubernetes platform engineering, DevOps, CI/CD. And whenever they have a requirement to a new job, then you'll be automatically getting an email from them to see if you are interested in that job. So uh, we are not relying on recruiters, because we are not paying recruiters for specifically hire jobs, but we are specifically relying on the AI agent tools. But we send your resumes to them. So you have more exposure. It doesn't mean they will talk directly to you. You don't have to come through us. We are not taking any cut from you on finding you jobs. So that said, let's move on. We can talk about cloud native, and why did the cloud native infrastructure was born or invented or created. We're gonna we're gonna talk about some of the concepts today. So let's move on. So again, this is part of the previous discussion about a high level of Kubernetes clusters. So cloud native architecture. So we're gonna learn more about cloud native architecture. We're gonna dive deep why it was created. So because everything is moving to cloud, doesn't mean the cloud native architecture that we cannot use that on-premise. Yes, we can. Only concept is you'll be running an on-prem cloud, or it's called private cloud, instead of using AWS, Azure, or Google Cloud. So if it's on-premise, think of it as a private cloud, but you will still be able to use these concepts and tools, even if it's on-premise. So traditionally, we face significant challenges when the internet hype happens in the late 90s and early 2000s. So everything was running on a desktop or a Linux machine that you're running in your office. So if you watched these videos from 90s, you probably have seen that people are working tirelessly on one of the machines that the actual users are accessing. Then they are upgrading the machine because they don't have enough RAM to accommodate the workload. And in the early days, applications were poorly designed, and they were they underutilized the resources. You put an application that thinking and that you'll be needing 8 gigs of memory, but the application will run for a year and you barely use 2 gigs of memory. So you are not using that 6 gigs, that waste of money, and it is underutilized in most of the resources, including the CPU, sometimes even the storage. So cloud native emerged as a concept or like a response to these limitations. It brought in a lot of wisdom from the infrastructure side, rather than writing the code, how to optimize this from the infrastructure end, other than optimizing your application just using the code or using a new algorithm. So the benefits, it enhance application availability. Now we can discuss more deeply. That means there are in early days there are application, if there's a load, you'll crash the application and the rest of the people will not be able to access your website. And it improved cost management, including resource utilization. So you're paying only for the resources that you're using, and also increased reliability. Uh, it's a loosely coupled system. That means you are not one service that you are building is not relying on the other service. We'll talk more about it. So it's the old way is tightly coupled. If you make some changes to your database, you have to make some changes to your application and probably into your UI code. So loosely coupled means you can make changes independently without affecting the other services that you're running. So that's the loosely coupled it's a service is what inspired the cloud native and sometimes the microservices before the cloud native hype. This came out of microservices, and then the cloud native concepts were born after that. So we'll go to the traditional monolithic architecture. I think if you have heard about it, if you haven't heard about it, that's fine. Monolithic architecture does not. Even I used to think monolithic architecture is like your whole code in one application or one artifact, or your WAR file or a zip file is your whole code. It doesn't mean, I mean, that's what it used to be in early 2000, but then they separate it out for the UI part and the business part and the database part, but it was still called a monolithic architecture because they were tightly coupled to each other. So even though they separate the UI, the business part and the database, they were still called monolithic applications until the microservices were born. Uh, and they did have limited flexibility and resource sharing in the monolithic architecture. So, like I said, so let's take an example of monolithic architecture. You have an user interface, which most likely or running Apache or Nginx, which you put some your HTML or CSS code that deployed on a Linux machine. So you build a Linux machine just for your UI code, and you have to have your dependencies, opening ports, and sometimes some different libraries for just for your UI code, and it cannot. It sometimes the people used to deploy it in a shared system. That means you have a UI code and your business code running on the same Linux machine. Then it comes to the point that you'll be sharing the same OS dependencies that you always. If you patch your machine, like you need to upgrade your OS, but it will work with the UI, but it will not work with your business code. So the kernel, the Linux kernel will not, probably the code is not optimized to work with the latest Linux kernel. So in that case, you have to separate out your UI code and your business code to two different servers and run them instead of sharing the same resources. So again, business logic, early days, it will be PHP, and now it's Java, and we end up sometimes now in the modern days there you'll be most of the JavaScript codes or React for running your business logic, even Python, Go, if you come more which is rarely used, but mostly PHP, Java, and the JavaScripts. So these are tightly integrated with your web server. Like I said, we had an issue with when we were patching the server. So we separated out the UI part and the business logic. And now your business logic needs to be tightly coupled with your UI. So any changes in the UI needs to make changes in the backend, which is the business logic. If you make any changes on the backend, then you probably have to optimize your UI uh, to accommodate that changes. So these are the limitations. So wherever you make some changes, you have to depend on each other. You cannot deploy the same code separately. You probably deploy the both of the code, the UI part and the business logic together, because they're tightly together, coupled together. And then we have data access layer, which is the database. So for your business logic to talk to the database, you have to optimize your server. Again, if you're running an virtual Linux machine, you'll be installing drivers for specific databases. So if you are changing your database, you have to change your drivers. You have to have host specific configuration. So any changes that goes into database, you have to make the same changes in the business on the business layer. That means you change the host name, if you change the layer name, if you change if you upgrade the database, you have to upgrade your business logic with the latest drivers. So any changes that we have done in the database layer, this also need to be done in the business layer because again they're tightly coupled. So this is what a monolithic architecture looks like. I know this is just the three layers, but this is the idea. So some applications have multiple business layers, multiple UIs, and multiple data layers. So eventually, wherever you make the changes, you will be depending somewhere else or some other team to make the same changes. So these things, when you're running a monolithic architecture, these things needs to be coordinated, properly coordinated. Sometimes you plan for a change for weeks, multiple meetings, wasting a lot of time just to make an upgrade or just to make a patch on one of the servers. And most of the time, these changes are done at nighttime because when there's the least number of users. Midnight deployment. So you'll be mostly working, you probably have worked, or if you're working on monolithic architecture, you'll probably doing deployments at night because if you make changes somewhere, you also have to make changes in another place, and the all needs to coordinate your database team, your platform team, your infrastructure team. So this is the problem that the IT industry face when it comes to monolithic architecture. So moving on from monolithic architecture, we have microservices architecture. Again, yeah, a couple of things I forgot to mention. So the libraries. So the different servers, the VM virtual machines, they have different libraries. if you run two services, even because monolithic architecture, they packed in one artifact or a WAR file or a zip file, multiple services packed in together one. And one service will be using one library, and the other services will have to have a different library. So if the VM doesn't have it, you have to install the other libraries. And if there's, for some reason, if there's the two services that use in the same library, again, if an update happens, if there's a change in the code, this application will not be able to use the same library. So we have to either we have to separate or we have to put two different versions of libraries and have to change the code again to each service point into the different libraries. Okay, go talk to this library in this location to make your services work, and the other services will talk to the other library. I mean, probably we have seen the multiple services running, but they're running on different Java versions, because the latest code or latest services that you add will work on the latest Java, but the old code will not work on the latest Java. So you will probably have seen, if you haven't seen, but you probably see in the old days, we used to have two different versions of Java running in the same virtual machine just to accommodate two different services, which we cannot separate out due to the coding bundling them together. Then eventually they'll be working another 6 months to separate out the two services so you can deploy them in two different VMs with two different Javas, and then talk to services to each other. So these problems seems to be old days, but I assure you these problems are still there. A lot of people are moving to microservices, but they break the big monolithic application into 5 pieces and call it microservices, but they literally monolithic applications with 5 different services. The real microservices is not breaking and once the microservices, like, you don't rely on the other services. If your big application, if you break it to 5 different pieces and if you're still relying on the other components, that's not microservices, just still monolithic applications, but break it into 5 pieces. So the cloud native approach. So cloud native approach is the microservices architecture. So it relies on the different from monolithic and relies on the microservices architecture. So like I said, the components are broken into smaller units, and it's managed. They are running on different services, different VMs. So again, if you're a small service, if you're using your own VM, yes, when it will come to, I mean, if you're not using containers, if you're running still VMs, because there are a lot of applications before they move into the containers, they had a monolithic application running on VM or bare metal. They break into the microservices, but they're still running in VM. That cause a lot of resource underutilization, because you're still using a big heavy machine like a virtual machine to run your microservices, which is microservices are supposed to use less resources because your pieces are small. But if you're running them in a virtual machine and it's not shared with other services, which usually don't do that in microservices unless they're containers. So they still are relying on a lot of resource underutilization. And this is the proper microservices. So you have your UI layer. For example, let's say this is Facebook, right? So you have Facebook portal that you log in. When you type in your username and password, and it will talk to the login microservices. From the UI, it will send a request with your username and password to the login services, and it will authenticate you. Okay, this is you, and it will let you log in. Once you log into the Facebook, then you can do multiple things. You can post your status, you can upload pictures, you can upload you can change your photo, your existing photo. Let's say if we want to change your photo, then once you log in, you go to update your picture, and that is a separate microservices that just to update your banner. I forgot what it's called, but let's say your profile picture. You update your profile picture, and it has its own database to store your profile pictures. Not all the pictures, just your profile pictures. So The UI will call the microservices that handle your profile picture. And if you're updating your status or writing something, it will talk to your status microservices, and it will store that in its own database, which is completely different from your profile picture. So let's say, and the same thing, if you upload pictures, it goes to different microservices, and those pictures will be stored in a different database. So this is what microservices looks like instead of bundling everything together. So you have different services, but once you log in for the UI, for you, everything seems together, like everything seems one. But in the back end, they have different services calling different APIs. So let's say if you want to make some changes to your profile picture, updating code, right? You can, without making any changes, touching any of the other services, while they're running, you can make your changes. You can do your deployment daytime. I'll let you know when it comes to the containers, how to do the daytime deployments. There are different concepts, right? So when it comes to daytime deployments, they initially came up with blue-green architecture. So blue-green architecture is not a cloud native approach. That was before the cloud native. So when people used to do deployments at night and including a downtime, that's when the blue-green architecture came. The users will be accessing the same set of servers, let's say blue set of servers and the green set of servers. And the users will, for once they're switching the route, so users will be accessing the contents of the blue servers. At the same time, during the daytime, you can make the changes to the green servers. You deploy the new code, you fix something up, you patch them. And once you update your green service, the request will route from your blue service to green services without no downtime. So that's the blue-green architecture before the cloud native approach, before the containers, because you're still running on virtual machines. But right now, you barely use, even if it's a big organization, you barely use blue-green architecture when it comes to containers, because containers really don't need to rely on two separate sets of namespaces or sets of servers that run in the same code when it comes to cloud native approach. Yeah, like I said, so you can deploy your profile picture without making any disruption for any other services, because barely, I think 2% of the people who are using Facebook probably updating their profile picture at the same time, or less, or probably less than 2%. So let's take the benefits of microservices compared to the monolithic. It encapsulated the configurations. So that means your configurations are for your own separate microservices. They have different component roles. It's very flexible for doing the upgrades or mixing the services. You can have your service call to different other services, or multiple different services can call to your microservices for microservices at the same time, and you'll be able to serve serve them even if they're different services. And they do have an independent networking for different microservices. What is independent networking? I briefly add a different part for here. So what UI does is, like, they come with different URLs, like so facebook.com/profile picture, facebook.com/status update, or facebook.com/ authentication or login for the login services. So when it comes over to the UI with different URLs, like facebook.com is going to be there, but after that it's going to be /login/profile picture/status update. What UI does is they are routing these requests to different services, which is called routing. We'll be using that concept in Kubernetes, but try to understand that the requests, when you click something in Facebook, it comes here based on the URL. UI will route that request to different microservices, because UI is optimized to route requests. It's like a routing rule if you work with load balances, but if you haven't worked with load balances, that's fine. But just try to understand it's routing different route into different microservices based on what you're asking, which is the profile picture, status update, or if you're trying to log in. So there are these specialized teams. You can manage your specialized teams for the code for your profile picture. A specialized team just working on your status update or the authentication part. If you need to update your authentication, there's a separate team working on just this microservices. So that gives you a leverage, which means that they don't need to really, the login team doesn't really need to know what's going on in the profile picture services or the status update or updating pictures. They really don't need to learn it. They only need to learn how to talk to this service. The people who are working on UI, they don't need to know how the logic on updating a profile picture works. They don't need to know the database. All they need to know, people who are running the UI code, if I get a slash profile picture, which API, which URL I should forward that request to. That's the only thing you need that these developers need to know. It doesn't mean like because in the olden days, everyone needs to know each part, because if you're making some changes, you need to know where can I break on the backend, whether it's the profile picture, if it's the status update. Before you make any changes in the monolithic architecture, you could break something on the backend. So that's why you always have to spend a lot of time try to coordinate with the other teams and plan a deployment. You probably do a good deployment a week if you're one deployment a week, or probably one deployment per day if you're in multiple deployments. So microservices, if I tell you a little background story, a few years ago, probably 5-7 years ago, there was a big story in IT about Netflix. Yeah, because these are the times that I think Netflix really got popular. And it come to know that Netflix was doing multiple deployments, like hundreds of deployments per day during daytime and during nighttime. And that sparked, because at that time, most of the people are doing one deployment a day, or probably doing multiple deployments over a weekend, because you don't want to disrupt your users. But when a Netflix engineer gave a talk in one of the conferences or IT conferences or something like that, and it explained how they're doing multiple hundreds of deployments in a single day without disrupting their users, while their users still watching the movies, and they'll be still doing deployments for hundreds of deployments per day. So that sparked the microservices, the discussion in all over the IT industry. Before that, there was few big organizations were doing microservices, and then everyone jumped in the bandwagon, and everyone wanted to do microservices. Again, it turned out to be a good thing from that Netflix story, and it's on YouTube. If you're interested, it's a few years old. Just go and listen to it. You could probably in YouTube probably go search for Netflix microservices architecture talk, because it was a presentation that was done in one of the conferences. Just if you have time, just go listen to it. It will give you more understanding for you. So let's go back to cloud native. Let's go into cloud native practices. So let's say if you're working for an organization and you did a deployment on Friday night, everything works fine. Developers verified, users verified, traffic started coming in. But on Saturday night at 3 a.m, you're getting a text message or a call saying, "Oh, something's break. Can you log in?" To support the application is not working. So how would you feel on your Saturday night? You spend your Friday night doing the deployment, and Saturday night, and probably you're enjoying the party up. Then you get a text message. It could be a Monday morning, and say, "Okay, if something breaks, come join in." So these are the challenges that cloud native practices trying to if you're trying to address. So, in Kubernetes, there's a concept of replica set. We're gonna talk in depth on this, but just gonna take it this example as for the scenario that we just talked. you get a text message in the 3 in the morning saying, okay, the service are not running. So in the Kubernetes, there's a concept called replica set. What it does, it manages the different pods, so different applications. So pod is like you're running an application in each one. What in Kubernetes, what it does, like let's say if this application, if this pod breaks, it stopped working, the replica set identifies that it broke, like it's not working, and it will replace with the new pod with the same application running without even setting a alert. When it breaks, the user request will not go in there. The user request will be served with these two pods, but the replica set of the Kubernetes will replace this pod with a new pod, and once it's fully ready, and it will start accepting the Kubernetes will start sending requests to the new pod. The moment it identifies that the pod it breaks, it's not working, it's not doing the health check properly, and it's automatically stops sending requests to that pod, and try to load balance the request to the different pods, and at the same time it's trying to spin up a new pod as a replacement, and it will terminate or delete the pod that's not working. So these are the things that on the old days that we have to log in the 3 in the morning, talk to the load balancing team, and and troubleshoot why is it not working. And we had to do the restarts. We had to make some changes. We had to tell the load balancing team not to send the request to this server. So all of these things that we used to do waking up 3 in the morning are done automatically in Kubernetes, which means less headache for you. You probably don't. Most organizations are running on containers or Kubernetes. They rarely have, even if they have a 24/7 team. This most likely for the applications. If someone says, okay, I have these questions, if they on their applications, but not on the infrastructure side. Even if they have people running 24/7, that's very rarely. Because if something goes wrong, it's really very rare that they'll be sending a text message or calling some engineer in the 3 in the morning and ask them to log in. So this is one of the major problems that the microservices architecture, including containerization, that fixes when it comes to infrastructure. So yeah, that was called self-healing, which is called you spin up a pod. If something breaks, you don't go troubleshoot it, you delete it, you spin up a new pod. So that brings on the resiliency and self-healing because it doesn't relying on an engineer to fix the issue. So a couple of key concepts. So here's like so this is what I just spoke about using replica sets on Kubernetes, automatically replace failed pods. So again, it reduces manual intervention. You don't need to intervene every time if something breaks. It implements automatic recovery mechanisms just in the Kubernetes, and you can have a sound sleep knowing that you will be knocked out or getting a call or a text message to fix the issue. Let me quickly check the time now. So we are half an away. And then the automation. So when it comes to Kubernetes or deploying containerizations or cloud native approach, most people rely on Ansible. But if you go back 5-6 years ago, there are about 3 or 4 very famous automation tools. One is Ansible, the one is Puppet, there's Chef, another automation tool, and probably there's I can't remember. There was a four main tools that did the automation. So the difference between Puppet and Chef and Ansible is that Puppet and Chef, you need to run an agent of like a Puppet agent or a Chef agent in the virtual machines that you do the update. But it can, which is pulling. You're pulling the changes. What the Puppet automation does is they're pulling the changes and making the changes. What Ansible does is you don't need to run an agent in the servers that you manage. It's a push concept. Ansible pushes the changes to servers instead of the Puppet and Chef that the pulling changes. So that is the main reason Ansible survives all these years. And eventually, when you're deploying cloud native applications or Kubernetes, you still rely on Ansible, and we'll be touching Ansible on automation principles when we talk about it. Terraform, yes, you'll probably use Terraform for the if your application is deploying in cloud. But if you don't know Terraform, but that you probably have to understand the basic concepts of Terraform. Again, we're not going to teach you Terraform, but we'll definitely touch on the Ansible. But if you are interested in deploying cloud components on cloud, please go ahead and if you're interested, we can learn Terraform. But we will but on our generative AI course, we'll let you know. We'll train you how to use a tool that you have never used before with the help of AI. So automation, many the minimal interactions when it comes to automation. So Ansible is used mostly in Kubernetes when you're deploying something for the first time. But after that, that's also if you're deploying on-premise. So if you're deploying something for the first time in the cloud, you'll be using Terraform. But all the other things will be using Helm and the other concepts of pipelining. Again, it comes back to the pipeline, CI/CD, which is really the concept that we are talking in terms of Kubernetes. So CI, which is continuous integration. As you can see here is so you have your code, user is running your code, and you commit to your Git repository. And from there, you're doing your build and unit test and integration testing. So this part is called CI part, because this part is a part that developers work with the CI team, or the continuous the team that manages Jenkins. In the olden days, it's Jenkins that does this, but when it comes to containerization, you can use different tools, but the developer will take over this part from the team that manages the Jenkins. What it used to do is, like, without the containerization, we build your code and put it in your repository, and if it's the first time, and you talk to your Jenkins team and say, okay, I have a code, I need to I need to compile it, which is building. I need to run unit tests on this code. I need to do the integration testing on this code. So they will provide you the pipeline. That means they will literally code on all of these things, which is the Jenkins team, and they will hand over to you to integrate with your code. So that's two different teams working together for the CI part. But when it comes to the cloud native containerization, you take over the unit testing. I guess you don't need to rely on different tools that you'll be using, which you don't need to understand the core concept of the tools that you're using, for example, pipeline. So the developer will take over this part in cloud native or the containerization architecture. So they are not, of course, there will be a team who manages it, but they will not help you run the unit test or the company. The developer will be doing that. And we'll be touch on these concepts. You don't need to, if you're on the infrastructure side, you don't need to do it, but it's very helpful for you to understand what's going on. And then we come back to the CD part. CD part is like continuous delivery or continuous deployment. In the next slide, we'll discuss what's the difference of continuous delivery and continuous deployment. So that's where you do you deploy your code. Again, in a monolithic architecture, you deploy your code or the WAR file or the zip file. And then the testing, again, you deploy again to a testing staging. If there's any changes, you come back, change your code, go back over here, run the unit test. And again, once everything's done, you go and deploy the staging. Once everything completed in staging, you deploy the same code in production. So that's the CD part, which is continuous delivery or continuous deployment. So again, the difference between continuous delivery and continuous deployment, which you probably need to understand. So continuous delivery is like continuous integration. CI part is same for continuous delivery, and you do have automated testing. So it's automatically test and release softwares based on your changes. And then it do the staging deployment. That means you are deploying in your lower environment on your stage deployment. So the testing team, the QA team can do the load testing and all the other UI testing. And at the same time, if there's a cybersecurity team, the cybersecurity team comes after you deploy into production. But I've seen cybersecurity teams that they have done penetration testing in the staging environment just to before you go into production for critical applications. So the QA and the cyber team comes in this stage to do the testing before you go into production. So the only difference is like continuous delivery, you have to do a manual production deployments. Continuous deployment is you do a automatic deployment. The Netrix uses continuous deployment because even for last 5-7 years, they are not doing any manual deployment. You check in the code, it run all the tests. Once you get the test report, if it's up to 90% good or 95% good, you go to staging, you run a couple of testing in there, and if those tests pass, these tests are like not based on the percentage, you have to pass or fail. Once you pass them, then you do a deployment without knowing it. Nobody knows that you're doing a deployment. You don't need to send an email announcing, "Oh, we are doing a deployment. Watch out for the interruptions." So this is what Netflix did. They did continuous deployment. That's how they were able to deploy hundreds of they were able to do hundreds of deployments in a single day. Again, like I said, which sparked the microservices discussions. And then moving on, security practices in cloud native. One thing I need to reiterate. In cloud native, you can pick it up. You can decide, basically the organization which will decide who will be doing whether they'll be doing the continuous delivery or continuous deployment. And based on that, you'll be working on your Kubernetes clusters and with the other tools to accommodate that. So if you're doing manual deployments, you'll be writing code, the Ansible code or the Helm charts with integrating with your Kubernetes cluster for the continuous delivery. If they're doing continuous deployment, you'll be making changes for that. So I guarantee you, at the end of the course, you'll have a full understanding on all of these concepts. But today I want to go through what we'll be discussing on high level. So these are just information. These are not anything technical, but we will dig deep into the technical part coming up. The other concept on cloud native is like security practices. These are by default, they are secure. So so they also, a couple of years ago, again, it comes this new concept like DevOps for networking. They came up with this new concept of zero trust security model. That means you never trust, you always verify. You don't trust someone for in terms of services, like in microservices, right? So if you're microservices, if you're getting a request from another service that appears to be has the same domain as the organization, you don't take that request in just because it seems to ask what you have, or it seems to have the same the request originated point from your organization. The microservices are designed, the zero trust architecture is to design always verify, even if you trust that services, even if that services talks to you hundreds of thousands times before or over the last 5 years. If a new request comes, you don't trust it blindly. You always verify it. One of the concepts, the Kubernetes also internally use that same concept on never trust, always verify. So this model into the Kubernetes is built in for talking to the Kubernetes components. But if you deploy something if you deploy some application and that application needs to talk to another application, and those two applications needs to code the never trust always verify part into their code, but Kubernetes as a whole comes by default comes with never trust always verify. It always relies on authentication either by the token. So we will talk more on authentication part when it comes to cloud native, but highly it's either token or username, password, or a certificate. So these three are the ones that we highly used for authentication when it comes to microservices. Again, component security, secure inter-services communication. This is what it means. Like even if you're running in the same cluster, each services has to verify the other services before you send something to them, because if your services are hacked, someone else can pretend something else and talk to different services and get all their details. So that's why you always these are by default always verified before trusting each other. Again, yes, comes to the Kubernetes cluster. What it does is what Kubernetes uses is, like I said, we have tokens, we have our username, passwords, and certificates. Kubernetes use tokens and certificates to trust or the verify different services that talk into each other. For as you can see, Kube API getting multiple requests from different services. So Kubernetes API needs to verify each of the services before it serves what they're asking. So by default, they're using mutual TLS, which is, again, I wasn't planning to add this part to this course, but I will add a course, probably a section on SSL, like, what's a mutual TLS, how TLS authentication works, because you need to understand how a TLS handshake works. Originally, I wasn't planning to add it, but I will add it down the line. You need to understand how SSL handshake happens. If you need to if there's enough need to troubleshoot any issues on your microservices. So that's SSL, understanding SSL handshake is a core concept of troubleshooting any services. If it's a microservices, if it's on-premise or cloud, you need to understand that concept. So Kubernetes is using mutual TLS certificates to trust each service. So let's say you deploy an application here, right? So this application that you deployed, which is running on a pod, it needs to access there's some services or something on Kube API server. Or if it needs to access this, if this service needs to access this, they'll most likely be using tokens on each namespace. So I'll come back to this when we talk in depth on Kubernetes, but Kubernetes will use tokens and certificates to verify each service. Again, I'll come back to auto. Okay, this is auto scaling, which is another concept. We talked about automation. We talked about CI/CD. We talked about security, and now we're gonna talk about auto scaling. So auto scaling, by definition, it says automatic or automated scaling of infrastructure or application components. Auto scaling does not mean it's not something that is only for cloud native or Kubernetes. Auto scaling is there on AWS and Azure, and it's there on-premise devices if you build an auto scale, which hardly happens because cloud auto scaling solutions are much easier because they are managed. And then the concept is pretty old, not new to the cloud native or Kubernetes. It's been there for at least 12 years. So what it does is automatically scale your infrastructure based on metrics that you specifically require. I mean, specific requirements. So there's the metrics and specific requirements for this. And it enables like dynamic infrastructure adjustment. Dynamic means like it happens whenever needs to happen. We don't need to decide when the scaling happens. It dynamically happens whenever the requirements are met. So auto scaling again, yeah, auto refers to automatic and automated. Scaling means you going up and down. It doesn't mean always going up, it goes down, and it's different concepts that we'll be talking. One of the benefits of auto scaling is the cost implications. So when it comes to cloud, because cloud is very expensive, uh, because if you made because there's a story, a developer made a change. This is not a big organization. This is a small business. Developer made a bug, and the average cloud cost was about $60 a month, about $60 to $70 a month. It 100x for a day. It went up to 65,000 because of a bug. Because the cloud is very expensive if you don't optimize your services to work on the cloud. So that's one thing that you need to understand when you're in an interview. You always based on their requirement, you always have to show that you know cost optimization on cloud native, because it's not a few years ago. Cost optimization on cloud native is not a big thing, but right now with the cloud computing prices going higher, that cost optimization is something that you need to keep in mind when you do something new. um, Again, yeah, scaling matrix. So like as mentioned, there are different matrix and requirements when it comes to auto scaling. One of them is matrix, your CPU utilization, memory utilization, and custom application matrix. That means the matrix that we search within the application. And again, storage is also there. So these are the matrix. You set CPU utilization. If CPU utilization is above 70%, you trigger an auto scale. If memory utilization is above certain percentage, you trigger auto scaling. If there's a different customer matrix that the customer needs to know based on the application, if it hits that trigger mark, I mean, if it hit that threshold, you will auto scale. So you can set it up all of these. So you can either scale up or scale out, which is called horizontal auto scaling or vertical auto scaling, which we'll talk. And there are three different types of auto scaling. One is reactive. Reactive means that some threshold is hit, and then you take the action to auto scale. You don't auto scale before the threshold are hit. There could be the CPU memory network threshold. So if the network output is hit a certain threshold, then you auto scale your load balances. So these are respond to real-time matrix. That means you always have to hit the threshold to trigger the auto scale. Another concept is like scheduled auto scaling, which is just planned auto scaling. You plan the auto scaling based on the time, based on the season, uh, um, or the use cases. Because in the Monday morning, you can schedule to scale up your services or your VMs or the pods uh, on Monday morning, because over the weekend you schedule to scale them down. So if you are at an online market, e-commerce market, if you're working on advertising, during the Black Friday, you scale up. Even weeks before the Black Friday, you scale up your services through the Black Friday and through the Christmas. And on January, you scale down. So these are schedules auto scaling. It can be seasonal. It can be day. I mean, you scale up during the day, you scale down during the night. So scheduled scaling is based on the time. It could be day or the year. And then we have predictive auto scaling. So predictive auto scaling, I mentioned AI. Predictive auto scaling is not new. A few years ago, there was a concept called ML ops. ML ops means machine learning ops, like DevOps. But that means they will leverage the machine learning based on the data that they have collected for your organization. All the metrics that you have collected so far for the last year or last 2 years, they train their models based on the matrix, and they identify when to scale uh, your services. It based on pattern recognition, historical data, or like intelligent resource allocations. They scale before something happens. Like they scale up the services before the thresholds are hit. The machine learning models will understand based on the patterns and the historical data, when to scale up and when to scale down. So that's predictive auto scaling. That's also part of ML ops. If you're interested, just search for the ML ops and which is machine learning operations. Again, not new, which is older than platform engineering, but its concept is there for some time. So what happened in real life is for ML ops, no organization will train models for their matrix, but they will buy some services like from App Dynamics or Instana uh, for monitoring services. So for monitoring services. And these tools, the App Dynamics, Instana, they come embedded with MLOps. That means they can, if the organization choose, they can optimize these services for the machine learning uh, based on your data, have it run it, optimize your services to trigger an event. So these services, App Dynamics, and they predict and they trigger the event, but that trigger event will talk to the Kubernetes or the cloud to scale up the services. But they will scale up before the thresholds are hit. So yeah, different scaling types, vertical auto scaling and horizontal. Vertical auto scaling is like you add CPU, memory, or storage to your existing VM. Like if you have 4 gigs of memory, you manually, someone from the infra team you go manually and add another 4 gigs or 8 gigs to that VM, because that's vertical. You don't you increase the resources of a single VM, which is called vertical auto scaling. So again, so example, so VMware, Hyper-V. So these are virtualization hardware or the tools. So you make the hardware changes like the storage, memory, and CPU. But what is horizontal auto scaling is you expand. So which there's a concept called commodity computers. That means your application should be able to run in a commodity computer. Means that your computer should have uh, 4 gigs of memory, like 8 gigs of memory, four cores of CPU. Um, and your application should be able to run. But how to scale those kind of application is horizontal auto scaling. You don't go and add a lot of memory to that VM or the computer. You create another replica of the same computer. You run in 2 computers or virtual machines. If you want to scale, you can scale to 16 with the same number of CPU and memory to that distribute the load. And the reason is like, let's say if it costs like $100 for 2 CPU and 4 gigs memory, if you 10x, right? So if you add 40 gigs to a single VM and 20 cores, it's not $1,000. It could be 3,000 or the $4,000 machine, because you add a big you add memory into the existing VM you're building up. The cost goes vertically instead of if you 10x your resources, cost doesn't 10x, cost maybe 40x or 30x. So that's why the concept of commodity computers come. You build cheap computers, but your application should be able to run in a cheap computer, like in a cheap as in not in price, of course in price, but in the low memory and CPU. But you should be able to scale it. Means you have to have multiple computers. That's what horizontal auto scaling means. Again, serverless. We'll talk about serverless because again, this is a concept in cloud native. Even if you are working on cloud, a lot of things, a lot of organizations are talking about serverless, which initially they said, okay, the containers, because we came from hardware to virtual to containers, and then we are moving to serverless, right? So everyone started to say, okay, the containers are done. Future is serverless. We don't need the containers. Containers is like virtual machines. Nobody's going to work on containers. Future is serverless. But when it comes to understand is serverless is actually doesn't mean there's no server. It actually means there's no server for you to manage, but the service managed by a cloud service or different service. But it's still going to be a server, most likely
like 100% of the time it's going to be a container. That means serverless means your organization does not manage the service, it's someone else managing, but you only focus on your code. So a couple of things it's like exist but managed by providers. Again, managed is there's a managed services, and these are on demand. You don't if you run something on server, you always have to manage the server. You have to keep the server up and running 24/7 because you don't know when the request will come. To serverless containers a spin up based on the requirement. So these are called event driven architecture. Not suitable for everything. You cannot put everything in event driven. You still need to have containers running, but services that are randomly used, you don't need to run a server 24/7 for a service that's only access over the weekend or only on Friday evening. For those kind of services, you can have serverless. When someone logged in for event driven is like if someone logs in, for example, so these are not real. I'm trying to simplify this, right? Let's take this Facebook example, right? Not everyone updates their profile picture like they update their photos or status updates, right? Or adding friends, right? So let's say if someone wants to click the button that says update your photo. So the moment that you click it, it's an event triggered saying that okay, there's this guy going to update the picture. So that event triggers for event mostly use Kafka. Just remember Kafka, we don't need to learn about. If it's an event driven, most likely they'll be using Kafka as a tool. So event triggered and let the managed services know that someone is going to update the profile picture to spin up the container that hosts the profile picture update in microservices. So if the request comes, if we decided to update the picture with the new one, the request will come that microservices will accommodate it, put the picture in the database and update its profile. And if the event never comes, that serverless container will dies after a certain time if there's no event comes in and if it decided not to update the picture. So that's oversimplification, obviously. But that's the concept on event driven and serverless architecture. Yeah, so again, key benefits: no servers to maintain, no infrastructure. You don't need to worry about the automated services, automated system updates. You don't need to patch any of these services. The managed host will work on this, and again, reduce operational overhead. Infrastructure abstractions, as there's no need for choose the hardware. You don't decide what kind of CPU, memory, or storage that you need to run. It's all managed based on the code, it will manage by the services. Say again, no CPU costs to worry about. Everything managed by the provider. But the one thing you need to understand is most like a container. I mean, not most like, it's 100% a container running your serverless code. Then we have function as a service. This is something that came after serverless. So function is instead of the key concepts, right? So function as a service is Lambda is a AWS Lambda is a function as a service. What it does is you upload your image, container image, or zip file. And again, event-driven architecture, automatic scaling. Going back to that profile picture update based on serverless. So we talked about one person updating a profile picture. Let's say what happens if 100,000 people at the same time clicked updating the profile picture, right? So then it will generate 100,000 events. Based on the events, instead of creating a one container, it will create maybe 10,000 containers. Scale up, horizontal scaling, scale up your serverless components based on the number of events. So that's something keep in mind. And then there are concepts like paper execution. So again, these are managed services. They decide how to charge you for your serverless deployments. And they have scaling characters. You can scale from 0 to 10,000 or even 100,000 Um, it handles thousands of events. Like I said, 100,000 events. All these 100,000 events will trigger one, but based on the number of events, it will scale up. Again, cost management for serverless is very high because you save a lot of money. You save money on resources. You save money on infrastructure. So out of these cloud serverless and on function as a services, what do we have on Kubernetes? Kubernetes also gives two different services for this. So let's say if you are running a Kubernetes services on-premise, because when I say on-premise, it's most likely a different data center, because if you have experienced, if you have heard that containers always run on cloud, it's not the case, because the Kubernetes or containers run on-premise even in bare metal machines. So for example, OpenAI, I think I've given this example before. OpenAI trains their models on Kubernetes, but they don't, to train an AI model, they don't use virtual machines or hosted services. They use bare metal servers because they need huge number of memory, GPU, and CPU. So GPU that NVIDIA creates the next gen GPU, the H100, H200, these are like really big GPUs, and you cannot use a cloud service if you're training an AI model. But right now, cloud services are giving access to these new GPUs. But the organizations that don't use, you need to plug in this GPU into a bare metal rack server. So uh, I've seen a lot of organizations that do AI training. They run bare metal machines, Kubernetes bare metal machines. So when it comes to Kubernetes, not just cloud, you run on bare metal, or not just cloud and virtual machines, they run on bare metal. So there are different solutions for the running bare metal Kubernetes. So let's say if there's an organization like that, they're running bare metal virtual machines. Do they have if they decided to go serverless or solutions, they can rely on Kubernetes as well. So there are two concepts on Kubernetes: Knative and OpenFast. OpenFast is like open source function as a service, which you don't have to pay. Knative is Kubernetes cloud native for serverless functionality. So keep in mind in an interview, if they come to ask like, is there a serverless option for Kubernetes? Like if they asked, if most of the time they will give you a problem and they will ask you a solution. So if it's a problem that you think that you may need to that you can accommodate that service based on serverless or function as a service, and you can say you can use Knative if you rely on Kubernetes, OpenFast. So it's the same concept, dynamic pod scaling. So instead of AWS running containers for serverless, Kubernetes will be using pods. They'll automatic load balancer configurations. It has all the serverless functionalities as Lambda or any other managed serverless containers, and dynamic pod auto scaling. OpenFast, again, alternative open source for function as a service. Is compatible with Kubernetes. You can deploy OpenFast on Kubernetes clusters, and it's again container based. So function as a service in cloud is like you deploy a function, like a snippet of code, not the whole code, just a snippet of code. You give that zip file, upload that into for example, AWS, the function as a service or Lambda. And when the event triggered, they will just run that snippet of code. They're running, no, not running whole application. They just run that small code, small function that serves that request. So when it comes to when it comes to a serverless, it's most like an image, like an application or microservices. But when it comes to function as a service, it's just a little part of a function or a snippet of code. Think of it as serverless is like an image or like a whole microservice. Uh, function as a service, like you're running a snippet of code at any given time. So these are the main concepts. Let me check the time quickly. Yeah. So if you have any questions, you can ask. I think these are the high level concepts that I want to talk. If you have any questions, yeah, let me know. You can ask in the chat. So from the next class onwards, which is on Wednesday night, 7. I mean, we can push into 7:30, but we'll stick to 7. If you cannot make it to 7, I'll send the recording for you to watch. So if you have questions, so these are the high level concepts. All of these things, the reason I did this, I want you to get familiarized with these words or the concepts before we dive into containers or Kubernetes. And in next week, we'll do some brief introduction. Just before jumping into containers, we'll do some brief introduction on a similar concept. We did cloud native today, but we'll do similar introduction on concepts on containers or the Kubernetes on the next class. And of course, we'll dive into the containers, starting with Docker. Yes, if you have any questions, just type in. If you think this is too much for you, we'll send the recording by tonight, hopefully tonight, and you can go through it, review it. If you have questions, come back on Wednesday, and you can ask the questions. Okay, I have a question. Okay, 7:30 p.m. works for. Is everyone okay for 7:30 on Wednesday? I know Arak also mentioned 7:30. So let's do this. Let's do 7:30 on Wednesday. We'll do for about a couple of hours on Wednesday. Yes, Nitin, thank you. Yeah, so let's do 7:30 on Wednesday instead of 7. I'll send an the updated. I'll send an link to the meeting on Wednesday. Yeah, so these are concepts. So if you, yeah, I don't want you to jump directly into the containers without knowing the background. In the next, on Tuesday, we'll talk about history on the concept that you're using, because then when it comes to Kubernetes, when you heard about namespaces, networking, CNI, isolation, network isolation, these concepts I'll be talking on Wednesday, but you need you to get familiarized with this concept before you jump into the actual workload, hands-on. One thing I want you to have is, does everyone have a Docker account? If you don't have, just go to docker.io, I believe, docker.com. Create an account for yourself for Docker, because you'll be using Docker Hub. You'll be using Docker Lab. There's an online website that helps you work with Docker. If you don't have if you don't want to run your Docker on your laptop, you have a website which requires the Docker a login account. So I will also send an two PDFs which to set up your local environment, which has things that you need to download to prepare for the hands-on. Follow them, and if you have any question, if you stumble upon, let me know. We can discuss. If you have a Mac, or I have a documentation prepared for a Mac and Windows, so I'll send both of them. Whichever machine you have, you can work on it. Yeah, but first of all, go ahead and create an account in Docker, which we'll be using going forward. And let's see, I have one more slide. Nope. Yes, so every day I will touch base briefly on how to prepare for interviews, what kind of questions. So the one thing that I based on the experience, that I think I really want to know, like if they ask, so there's one question that they always ask: why are you leaving your current company, right? So the best answer, I've tested this out. The best answer why you're leaving your current company is, you have to let them know that you got bored. Yes, you got bored in your organization because you don't have technical challenges, uh, challenges in that organization, or that you are not challenged enough. You have to say, I know I'm more capable, but I'm not challenged enough in my current position. Since I'm looking for new opportunities, new challenges, At the same time, mention that you have resolved, you have to let them know that how that the current organization that you're working on, how it was, and how you brought it up, how you automated things, how you created pipelines, have you improved the resiliency of applications, how you brought down the overhead of maintaining of the infrastructure. Let them know that you have done all of these things. There were good challenges. I enjoyed, I excelled them, but I'm looking for a new opportunity because I feel like I'm not challenged enough. It feels like day-to-day work, repetitive work, which I'm very, very bored of. Uh, so whenever you face an interview, make sure uh, uh, that you are not leaving because of money, because you are not leaving because you are laid off, not leaving because of office politics or anything. Keep these three things out. Always let them know that you are looking for new challenges. I face it. I enjoyed it. I'm looking for new opportunity because I want to challenge myself. I want to improve myself with the new technologies and everything. So obviously that's question that's the question they will ask in the middle of your an interview, but always let them know that you are looking for new challenges. Uh, you are moving because you are not challenged enough, or you are moving because you need to learn more new technologies. I've learned everything over there. I want to learn new technologies. I need to learn cloud or the cloud native. Need to learn the AI or the blockchain technology. Which are the technologies that based on the interview, because you will already know you're the organization. You obviously have to do a background check on what kind of technologies they're using. Yes, we'll let you know in our interview preparations on how to do background checks on organizations. But let them know that you are looking for new challenges, and that gives a positive vibe for them than someone moving because of the salary, or say I'm not getting paid enough. I'm looking for, or say I'm trying to buy a house. I'm not getting paid enough since I'm looking. That those are not very good answers for an interview. Yeah, that given that, I think we can conclude today's session. Remember to create an account in Docker, and also try to download the Docker desktop. If you haven't, my documentation will also let you know how to download a Docker desktop. But if you haven't download Docker desktop, we'll dig in next week on Monday on Docker. Uh, Before that, we're gonna do some concept, but then we'll eventually start with Docker. Yes, if you have any other questions before we conclude for today. No questions, I see. I hope I did well. If you think I need to improve on explaining, if you think I'm repeating the same thing, just let me know. I'll try to improve myself as well. But if you need to, if you think I'm going too deep, if you think I don't need to go too deep, just also let me know. If you think I need to go deep, explaining more in depth, just also let me know. We can spend time on understanding the core concepts, because you need to understand core concepts before you jump into hands-on, and then we can, it would be very easy for you to understand on these things. I guess that's it. Again, thank you for joining. If you have, seems like no questions, thank you for joining. If you have questions, email me. In meantime, while you're working, I will send the two documentation on how to set up your local environment. Make sure you get your Docker desktop. If you can, if you have time, go watch that Netflix presentation that they did a few years ago on microservices. It's very, very exciting. Think this is like 7 years ago. But start with that. I will recommend you more new videos or talks from industry going forward for as a homework. I mean, obviously you don't have to listen to it, but if you listen, you'll learn more knowledge, and it will be helpful for you to face the interviews. Yes. Again, thank you for joining. Let's close the meeting. See you on Wednesday at 7:30 p.m. Thanks.
Thank you, Chiran.
Thank you.
Thank you.
Yeah, 120.